Hello folks, we come to the part 4 video of this exercise 5.5 and we'll continue with our derivatives and we'll see how we can find the derivatives. Now one problem that is common, one thing that is common between both the problems is there are sum of two functions that is given. And I've told you that whenever we are given sum of two function, overall logarithm doesn't help us. We have to take it in pieces and then take the logarithm and revert back. So both the problems we'll have to take this as u, this as v, do it and then come back. That is what is going to help us. So let's see right away and go right away and do the problems. Let first to start with, we will call this as y, and because we have realized the problem, we are going to call v as the first part, u as the first part, and v as the second part. Now if you have u as log x raised to x, that is function raised to function, we cannot move without taking a log. So we take a log of log x whole raised to x. So exponent comes on the side and we get log x. So we are ready to take the derivative. So on this side you have d by dx of log u and d by dx of this function x into log x. So here we know it is 1 by u du by dx, and here because it's a product we have the first function as it is, derivative of the second function, and second function as it is, derivative of the first function. Now this we have diffused. Log x, I told you before that we will require it many times, and it is 1 by x log x. So the derivative is 1 by x log x, and here log x is as it is, derivative of this is 1. The x's can cancel and you get the du by dx after taking the x, after taking the u on the other side, is log x raised to x times 1 by log x plus log x. Okay, so this is how our terms are coming up. If you want, you can equalize it. Actually no use, let it be that. And then we go for b. Also our b is x raised to log x. So we take the log on both sides. Log b is log of x raised to log x. So exponent will come here, log x into log x. Either you take it as log x the whole square and do it, or you take it as log x into log x product and do it. It's your wish. So we are taking the derivative now on both sides. Log b is equal to d by dx of log x into log x. So how is this coming? 1 by b dv by dx, and this is the product. First function as it is, derivative of the second function, then second function as it is, derivative of the first one. So this is 1 by b dv by dx, and this is log x, derivative of log x is 1 by x. Again this is log x, is 1 by x. So it is log x by x plus log x by x. Denominators are same, you can add the numerators. Log x plus log x is 2 log x by x. V will go there and will become x raised to log x. Right, so I got dv by dx. Okay, so that will make our y, therefore y which is u plus v will have dy by dx as du by dx plus dv by dx, and since we have everything ready with us, we can write du by dx is log x raised to x times 1 by log x plus log x, and dv by dx is x raised to log x times 2 log x by x. Right, so that's about it, and that is our problem number 7. Problem number 8, as I told, it's the same way. It's a sum of functions, so you have to take individual things, but derivative will be slightly simpler for the next one. Let's see. So let's call this as y to start with, and let u be sin x raised to x comma b be sin inverse of root x. Now if you take u as sin x raised to x, because it's a function based function, there's no other option rather than taking the log. So let's take the log. Log u is log of sin x raised to x. The exponent comes on the side and you get log sin x. Okay, so taking the derivatives, taking the derivatives, d by dx of log u and d by dx of x log sin x. So product, so it will be x times derivative of log sin x and log sin x as it is derivative of x. Okay, now this is not so easy, right? So we will just consider that and take the derivative. Consider z to be equal to log sin x, and in this case let's consider some r or w. We have w to be sin x, like that z will become log w. So w with respect to x will become cos x and z with respect to w will become 1 by w. Our idea is to get dz by dx. So that is dz by dw into dw by dx. Okay, what is dz by dw? It is 1 by w. Yeah, we know what it is. 1 by w into dw by dx, it's cos x. So 1 by w, it is 1 by sin x and cos x, so cot x. So what do we get? dz by dx, we have got it as cot x. So actually this is going to be cot x. So let's revert back from 1 and 2. From 1 and 2. Okay. We have 1 by u du by dx when we take the derivative here, right? And this is x times, we have got this as cot x log sin x. Derivative of x is 1. So basically your du by dx is going to be, u goes there, so it is sin x raised to x times x cot x plus log sin x. That's your du by dx. We come back to b now, and also your v is sin inverse of root x. For this root, let's make a substitution and let r be root x, so that v becomes sin inverse of r. dr by dx is 1 by 2 root x and dv by dr will be 1 by root of 1 minus r squared. We have learnt it. All this we have learnt. So we require dv by dx, which is dv by dr into dr by dx. dv by dr is 1 by root of 1 minus r squared and dr by dx is 1 by 2 root x. Now what is this r squared? R is root x, so r squared is x. Just check. R squared is x. So this is going to be 1 by 2 root of x into 1 minus x. Just check root x here. This is 1 minus x. That is your dv by dx. So what is going to be your dy by dx? Y is u plus v. dy by dx is du by dx plus dv by dx. So du by dx is all this. Sin x raised to x times x cot x plus log sin x plus 1 by 2 root of x into 1 minus x. It's worth like cross checking by any chance if something is missed. 8th. Yeah, perfectly okay. So that's math. Quite a lot of work to do, but if you're a little systematic, you will not miss on things. Be a little haphazard, then things are totally helter skelter. That's about it. With new problems, we'll meet in the next video. Thank you.